Okay, so they give us a function and it says determine the local behavior. For us, that's going to be finding the y-intercepts, the x-intercepts, and the turning points. The number of turning points, I should say. Number of turning points. Okay, notice that it's in a factored form. That's going to be great when we want to do the x-intercepts, but for other things, we would like it in the general form. So let me recopy it. And let's multiply the binomials out. And then let's distribute the negative 4x. Okay, that will help us to have it in both. Okay, so for the y-intercept, that means what's f of 0? Well, everything's going to go to 0 here, so that's just going to be 0, right? Okay, so that's the y-intercept, 0, 0. All right, now let's look at x-intercepts. So x-intercepts, I want to go back to the factored form, negative 4x, x plus 3, x minus 4, and find those x-intercepts. I'm going to have one at 0, one at negative 3, and one at 4. So as ordered pairs, you're going to have 0, 0. That's an x-intercept as well as a y-intercept. You're going to have negative 3, 0, and you're going to have 4, 0. So here's my y-intercept. Here's my x-intercepts. What's the number of turning points? Most. What's the highest number of turning points I can have, or the most number of turning points I can have? Well, it wound up being a third degree. So the most number of turning points I can have is 2. And that's going to be it for us for finding the local behavior.